Hello, I am Selvi, Department of Computer Technology. Let me give you a topic of inheritance in data structure using C++. Object-oriented programming can be defined as a combination of abstract data types with inheritance and dynamic binding. Data abstraction has two-dimensional and inheritance has three-dimensional. Inheritance is nothing but specifying hierarchical relationship between types. C++ classes can inherit both data and function members from other classes. Terminology is known as the child type inheritance, the parent types. The derivative type is just the base type plus first one added specializations and the second one added generalizations. What a derivative class inherits? Every data member defined in the parent class, every ordinary member functions of the parent class. What a derivative class doesn't inherit? The base class constructor and the destructor, the base class assignment operator, the base class friends. What a derivative class can add? New data members, new member functions, new constructors and destructor, and new friends. When a derivative class object is created and destroyed, space is allocated for the full object. The base class constructor is called to initialize the data members inherited from the base class. The derivative class constructor is then called to initialize the data members added in the derivative class. The derivative class object is then usable. When the object is destroyed, the derivative class destructor is called on the object first. Then the base class destructor is called on the object. Finally, the allocated space for the full object is reclaimed. Inheritance in C++. The class header is modified to allow a derivations list consisting of base classes. Key properties of C++ inheritance. The is a relationship is maintained. The pointer to the base type may point to a derivative type object. The above relationship combined with a dynamic binding promotes a type secure polymorphic style of programming. This is the derivative from screen. Derivative from Windows. Public with private inheritance. The public keyword in the inheritance syntax means that publicly as accessible members inherited from the base class stay publicly accessible in the derivative class. But sometimes it's preferable to inherit the public members of a parent in such a way that they become private in the child. Private inheritance. Public members of base class become private members of derivative class. Public and protected members are only available to derivative class member functions, not to a derivative object. Protected inheritance. Private members of the base class aren't accessible in the derivative class. Protected qualifications allows encapsulated data members which are not publicly accessible to a accessible by derivative classes. Protected members are not accessible from outside the class except in derivative classes. Initializer list. Derivative class constructor automatically calls the new argument base class constructor. Initializer list. These programs are example of initializer list. Using initializer list to initialize values. Initializer list can also be used to initialize class members with a specific value. Polymorphism. This is some code on operations or object behave differently in different contexts. Member function with the same name can be implemented in different classes. Appropriate versions of function is determined at runtime dynamically. Virtual member function used to implement polymorphism. Polymorphism, dynamic binding. At runtime, the C++ program selects which member function to execute. If the function is virtual and exit at the different levels with the inheritance hierarchy. constructs with static binding, emp dot display employee info of semicolon. Thank you.